Everyone, I'm Abu Michael, aka Abu Miki, your online maths, physics, and electronic tutor. I'll be looking at the 555 timer. Now, this is actually an 8-pin, or you can call it an 8-DIP device. It's an IC, and this IC is very versatile. Trust me, I've used this IC in doing some stuffs. I did something in my house. It's an indicator to let me know that there is presence of voltage from my local power authority. I used it to design a switch to tell me that the tank is water level indicator for a tank. I've used it to design a kind of touch switch. I mean, the applications are actually limitless. You can use the power timer for timing. You can use it for free oscillations. You can use it for generating pulse signals. You can even use it to design an inverter. So I'll be showing you a couple of things that we can use with the 555 timer. But in this class, I will just look at some of the features and I will tell you one of its application. And if you are very creative, you will have a lot of things to do with the applications of the 555 timer. Now you can use it in logic circuits. It can be used as a NOT gate. And if you do some manipulations around it, you will have a very good device that is working very well for you. Well, this 555 timer, as you can see from my diagram below, it has 8 pins, the ground, the trigger. You can see them on the screen. Now I will be particular about just some of the pins. I won't talk about the ground and VCC. I believe you have an idea of what ground and VCC is. So I will concentrate on the pin 2 and 3 like that. Now see, now pin 2 is that pin we call trigger. And the way the pin 2 works is this. When pin 2 gets a low voltage, when pin 2 gets a low voltage, pin 3 goes high. What that means is you use a low voltage to trigger pin 2, then there's presence of voltage at pin 3. So the presence of voltage, we say it is high. When there's little voltage or very little amount of voltage, we say it is low. Now this voltage at pin 2 has to be at a particular level. Now if you look at the internal structure of a 555 timer, you will see that it has 3 5K resistors there. So let me just do a kind of mimic of the resistor. Okay, so that's resistor 1, 5K, 5K, 5K. Now as a student of physics or mathematics or electronics especially, if you check this arrangement, 5K ohm resistors, 3 of them in series. So the voltage across them, for the voltage here, this will be 1/3 of VCC. This will be 2/3 of VCC. Then this is 3/3 of VCC, which is actually VCC. Okay, so if you look at the internal structure of the 555 timer, you will see that the 1/3 VCC is connected to the op amp that the trigger is connected to. So if you look at that place, you will see that it is the 1/3 of VCC that is connected to the op amp that is associated with the trigger. If you look at this other side, you will see that it is the 2/3 of the VCC that is connected to the op amp that is associated with pin 6, the threshold. Well, when I start talking about threshold, then I will highlight that. So if you want to activate the 555 timer, it needs a low voltage that is less than 1/3 of VCC. So guys, excuse me, we need a low voltage at this place. Oh, I just rubbed off the title. Oh, that's funny. I just rubbed off the title. Okay, all right, guys. So for pin 2, our voltage should be less than 1/3 of VCC. Now let's say, for example, you are supplying 12 volts. The 555 timer can actually take between 4.5 volts to 15 volts. Sometimes you can even say 4 volts to 15 volts. Some books might even write 3 volts to 15 volts. So to be on the safe side, maybe you should just take 5 volts to 15 volts, right? So let's say we are using 12 volts to power the 555 timer. 1/3 of 12 volts is going to be 4 volts. So if I get any voltage less than 4 volts, even if it is 3.9 volts, I have triggered the 555 timer. And when we trigger the 555 timer, the result is pin 3 comes alive. It becomes happy. It gives you voltage, and this voltage can be used to do stuff like power an LED, drive a buzzer, drive a transistor. It depends on whatever you're doing. You can use it to drive a small speaker. You can use it to do whatever, as long as the voltage is sufficient to drive that. Okay, so that's it about the trigger. Now the output voltage of the 555 timer is such that the output is many times VCC minus 1.5 volts. Yeah, VCC minus 1.5 volts. What that means is, let's say I supply the IC with a 12 volts. So what I may get as the output should be around 12 minus 1.5. That should be 10.5 volts. So if I power the IC with a 12 volts, I may get 10.5 volts at the output. Now, it's not like this is what you get every time, because at times the voltage may not even be up to 1.5, minus 1.5. It may be minus 1.4, it may be minus 1.3, it may be minus 1.35. It depends. Now the worst you can get should be VCC minus 2 volts, depending on the current you draw and the temperature you are working with. If you are working at, say, 25 degrees Celsius, you are going to get voltage from between 1.0 to 1.5 volts. Now when you increase your temperature, say is working at 55 degrees Celsius, for example, under a very hot atmosphere, hot environment, internally and everything, then you may have a 2 volt drop. Then the output will be VCC minus 2 volt drop. I hope that is clear. So that is basically what the output does. That's basically how the output operates. Now we have the reset pin. Now the reset pin is activated also with a very low voltage. So if you give the reset pin a low voltage, say 0 volt, 0.1 volts, it will stop whatever operation the 555 timer is doing and bring it to start again. So that's what it does. For the pin 4 not to reset, we basically many times by default we take it to VCC. Just leave it at VCC. But if this were a microcontroller, your reset pin will be very, very awesome, where you have to, in your hardware configuration, ensure that you make provision to reset your IC if there is probably a problem with the programming. Maybe get lost in the program, you can just bring it back to itself by pressing the reset button. So you can always add that, include that in your design. Well, your pin 5 is called a control voltage. Of course, everybody knows what control is. It means the pin 5 voltage has influence over the operation of the IC. Now we can use it to influence the voltage at the output. We can use it to change some of the characteristics of the 555 timer, especially when you run it in the stable mode. We can use the pin 5 to change the pulse width of the 555 timer. Now the threshold voltage, pin 6 works with 2/3 of VCC. So when we have a voltage that is greater than 2/3 of VCC, the threshold pin will be activated. Threshold, you know what threshold is like when you get to a limit. We use that feature many times with timing. So let's say with timing, when the voltage charges up to a little above 2/3 of VCC, then I think the discharge will just set in, the discharge setting for the operation for your application to work the way you have addressed it. It's a very useful IC. Your pin 7 is the discharge pin. Now we use the discharge pin to discharge the timing capacitor anytime your output goes low. This will ensure a smooth operation of your 555 timer every time you use it. So like I said, you can use the 555 timer in different applications, and like I told you, I've used it a couple of times to do crazy stuff, crazy designs. It's almost difficult for me to do a design without including the 555 timer. I just love it. I love its versatility. It's just great. It's awesome. If not for the fact that microcontrollers came and all that, I believe what people will be using in their circuit will be more 555 timer, more of op-amps, then some other stuff, But I think 555 timer will just play a major role in their designs. Alright guys, how do you use the 555 timer as a monostable? Let's see. The circuit is a simple one. I'll just draw a diagram. Let me see. As a monostable, you have a resistor, you have a capacitor, then you connect this part to pin 6 and 7 also, so then this part to pin 4 and pin 8. This will be the output, pin 3 via a resistor. Let's say this time we just wanted to power an LED. It's an LED. Then your pin 5 will be connected via a capacitor to ground. Then your pin 1 will be ground. Okay, I believe I have just itemized all the pin except pin 2. Now pin 2 is left alone because pin 2 is actually used as the trigger. Well, if you connect the 555 timer like this, what you get is the 555 timer will come on, it will run for a time period, then to stop. Then after it stops, there will be nothing to trigger it, so you just be like that. It will remain like that forever, so it will just work one time and will never come on again. As long your VCC is there, your 555 timer will just remain in the off state forever. And what will it be doing? It just be sinking currents, because the 555 timer have the ability to sink or to source 200 milliamp of current. I'll be explaining that later as I continue this video. So if you want to ensure that you can bring this timer on again, then we may have to do something to this circuit. So I will just bring out a pin 2 here. Don't mind the diagram, it's kind of funny. So a resistor. Let me just put the resistor outside. I wish I can just shift this thing. Okay, that's a resistor. Please pardon me, I'll try it again. A resistor with a pin, a switch. That's like a switch. Then this will be ground. It is this part of the switch that I'll connect to pin 2. Now when we do this, when you set this up, what happens the first time is, excuse me, I think this should not be there. Okay, so when you do this, what happened the first time is your 555 timer will come on for a time period that has been set by this resistor R, and this resistor C. Okay, this other resistor, this one that is here, this other resistor here is just to limit the current that flows through that line for your reset button. I think it's awesome when you connect your reset button like that. This is your monostable circuit. Very, very cool. It brings your LED for a time period. This LED could be your television, it could be your TV. You want your TV to work for 10 hours. Now 10 hours is pretty much, right? there's a way to go around it. You want your appliances to work for a time period before it goes off, probably maybe at night. Then you can use a circuit like this. You want your buzzer to make sound for some time period. We can do something like this. How do we calculate that time for a monostable? Now, to calculate that time for a monostable, we are going to do something as simple as this. The time period is 1.1 times RC. Sometimes I just use RC because I see little difference between 1.1 and 1. So sometimes I just use this to calculate, sometimes I use this to calculate. So choosing your time period is kind of very, very simple. It's not difficult at all. It's actually very, very simple. It's best you choose a capacitor value, then plug it into the formula, then you can have a resistor value that will work well. Let's say, for example, that I want a time of maybe 10 seconds and I choose a resistor value. Let me just use this formula RC. Let's say I want a time of 10 seconds and I choose a capacitor value of 100 microfarad. So I will have 10 is equal to R times 100 microfarad. Then my R will be 10 all over 100 microfarad. For those of you that are good with maths, my micro means 10 raised to the power minus 6. If I bring that up, I'm going to have 10 times 10 raised to the power 6 all over 100. Okay, so it's more like I'm having 10 raised to the power 7 minus 10 raised to the power 2. Also 10 raised to the power 7 divided by 10 raised to the power 2. That will be 10 raised to the power 5. So eventually our R becomes 10 raised to the power 5. 10 raised to the power 5 ohms. R is 10 raised to the power 5 ohms. That is your 100 kilo ohms. So if I want a time period of 10 seconds with a 100 microfarad capacitor, I will use a 100 kilo ohm resistor and I'm going to get approximately 10 seconds. Very, very, very awesome. So anytime you are designing for your monostable and you want a time period of whatever, many times it's best that you choose a capacitor value. Now if it happens that after calculating for resistor value, let's say you got let's say what you got was say 48, 5, 6, 7 ohms for the time period you require, and there's no standard resistor that's like this in the market. So what you do at this time is you can now use a variable resistor, maybe 50 kilo ohm resistor, and vary it until you get to something very close to this and you still get a very good time period. In my other videos, I'll be showing you how I put this up on my project board. Then I'll show you practical demonstrations of all of this, and I'll be explaining what it means to sink or to source current of a 200 milliamp, and I'll be showing you calculations around the 5 timer such that you're not going to burn it out. You're going to have a circuit that can run for years. I have a circuit that's been running for years, that's been running for a very long time. That's because the current consumption is very, very, very low and it's working perfectly. All right guys, I'm going to stop here. I hope you guys had a wonderful time with this video. You can make contributions, you can tell me what you want me to talk about. I'm open to corrections and suggestions. Thank you guys. Yeah, I'm just trying to add my own quota to the world of science, and that is what I'm doing now. Thank you guys. You guys are awesome. You guys are great. If you're an hobbyist, you like to do electronics, it's best to start practicing, because by practice then everything becomes perfect. You get it. You have to buy a 5 timer in a shop, in a rack shop. You have to buy one, go to a Radio Shack shop, get a 5 timer, get an IC socket, get a breadboard, get a soldering iron, get a screwdriver, get all of those stuffs ready and start putting stuff together. Before you know, you start making stuff yourself. Thank you guys. I'll see you in my next class.